Hi everyone, I am Dr. C. working as Associate Professor in Country Engineering Department at the Anderson College of Engineering and Technology, Kolkata. Today we are going to learn about draft, what is a draft, what is the function of the draft, why it is required, what is the efficiency, and what are the applications. First, what is a draft? It is a pipe of gradually increasing area which connects the outlet of the runner to the rail. So these are the various parts. One end of the draft tube is connected to the outlet of the runner, while the other end is submerged below the level of water in the tail. So this is a draft tube. It is a runner. It is connected to the turbine. So the turbine outlet. So we have to fix the draft tube like this. So it is directly coupled to the runner. Next, why it is needed? The draft tube is what is the purpose? Why it is needed? If the pressure exceeds of the turbine is lower than the pressure of the fluid in the tail, a backflow of liquid into the turbine can result in significant damage. By placing a diffusive pipe at the exit of the runner, the pressure that is increased by decrease the exiting velocity, and therefore the overall efficiency and output of the turbine can be improved. Turbines need to have a minimum amount of water to couple them in order to produce enough energy. Without this shaft tube, the pressure could drop because of lack of water, and the entire turbine could fail to work, and the power could be lost. And another important thing, in an impulse turbine, the available head is considerably high, and there is no significant effect on the efficiency. If the turbine is placed in a couple of meters above the tailbase, but in the case of a reaction turbine, if the net head is low and if the turbine is installed above the tailbase, there can be appreciable loss in available in the pressure. Next, part of the functions of draft tube. The primary purpose of the draft tube is to monitor the influx of water. The turbine has something called the drain, which is the lowest portion of the plant and construction project that the water tubes. The tube connects the turbine to the tailgate, permitting the turbine to be outside of the water, but still have access to water. Reduce the velocity of discharged water to minimize the loss of kinetic energy and the output. Then it permits negative head to establish at the outlet of the runner and thereby increase the net head on the turbine. The turbine will be placed above the tailbase without any loss of net head, and hence the turbine may be inspected properly. Also, it converts a large portion of kinetic energy rejected at the outlet of the turbine into useful pressure energy. Without the draft tube, the kinetic energy rejected at the outlet of the turbine is waste to the tailbase. So the draft tube prevents the splashing of water coming out of the runner, and it guides the water to the tailbase. These are the basic functions. And what turbine does not require draft tube? It is that used to increase the pressure from the low turbine exit pressure to the pressure of the surrounding to which fluid is injected. Only reaction turbines requires a draft tube, as there is a low pressure at the exit of the turbine, whereas in the impulse turbine, the pressure at the inlet and the exit is essentially the same, which is above the pressure to the which the fluid is rejected, and thus it requires no draft tube. So the conclusion is that only reaction turbine requires a graph. Then the types, what are the types of graph? There are different types of graph which are required to serve the purpose in the installation of the turbine or as soon as the first one is conical graph. So the conical graph, simple elbow, Moody's perspective, then graph tube with circular inlet and rectangular output. These are all the various kinds of graph tubes. The usage of these graph tubes depends upon the design of the turbine. Next, what is graph tube field? So the graph tube field is based on a technology. So in this case, we have to draw the line diagram. We can easily explain the graph tube field. So this is a turbine casing. This is the outlet of the turbine, and these are the outlet of the graph tube. In between, we have to fix the graph tube. So we have to consider this pressure. So in this case, it is a tail race. It is the outlet of the graph tube. So HS means it is a suction head in the inlet of the graph tube, tail race. We have to consider the two sections, 1 and 2. So we applying Bernoulli's equation in this case. So we know these equations. Here the exit, there is no losses, but loss of it due to friction is also available. Here there is no the datum level, but in the inlet section 1.1, we are having the Z is having suction pressure head and then another the tail race. So the tail race head is also called as small tail. Loss of energy between section 1.1 and 2.2 is denoted by Hz. So here the P2 is a exit pressure. It is a atmospheric pressure head plus. So PA by OG plus 1. So substituting these values in the equation 1. So this is the equation 1. What is the value of P2 by OG? Substitute these values. And again we have to reduce this equation. So we can calculate the inlet pressure head in the section 1.1. What is the pressure head in the section 1.1? That is the pressure head means P1 by OG. So we have to rearranging this equation. We can easily get the final equation of PA by OG minus Hz. These are the another kinetic energy minus loss of it. So in this equation, P1 by OG is less than the atmospheric pressure. So the outlet pressure will be lesser than the atmospheric pressure. So our purpose will be solved. Next, we calculate the efficiency of the graph tube. So the efficiency of the graph tube is the ratio between actual regain of pressure head to the kinetic head or velocity head of the entrance to the graph tube. So it is a conical graph tube. So we have to measure in the outlet side. This is a unit. So it is a shortest diameter. This is largest. So the shortest velocity is V2 and the outer larger one is V1. So V2 is also equal to V3. So we have to substitute this equation. Actual region regain of pressure head. So we have to calculate the pressure head, kinetic energy minus loss of pressure. So basically this equation is substituted in the various kinds of velocity. So we have to finally get this equation V2 square by minus V2 square or V3 square and then divide by 2G minus loss of due to friction divided by kinetic energy at the section 2. So this equation is helpful to calculate the overall efficiency of the graph. Then applications of the graph. It is a conduct which connects the runner exit to the railways, where the water is being finally discharged from the ocean. The primary function of the trap is to reduce the velocity of the discharged water to minimize the loss of